Hi, my name is Warren Togami. I am from America. I'm sorry, this is not in Japanese. I gave a similar presentation to this back in December, but I have a lot more information now, including a live demo of setting it up properly. So my background is I originally worked on the Linux operating system. I was a operating system engineer at Red Hat. My project at the university was called Fedora. And the operating system that I'm using right now and will be demonstrating on the install is Fedora 38, soon to be released later this month. I currently work at Blockstream. My recommendations on building yourself a reliable Lightning node and the hardware choices, this is entirely my hobby. Although my company makes Lightning software as well. Okay. So a few years ago, I was very angry when I saw people selling Raspberry Pi kits for Bitcoin nodes. And this is a very bad choice, and the prices that they were selling them were too high, and I knew that this hardware is not reliable. If you know hardware, Raspberry Pi is hobby quality, and if you're lucky, you'll get one that's reliable, but many of them are not reliable. Like who here has had a Raspberry Pi crash? Okay, yeah. If you want reliable hardware, you need to buy electronics that are built for reliability, like business quality. Wait, okay, not that yet. So, because I saw people buying Raspberry Pi kits, I tried to design the perfect board for Lightning from 2018. And we built prototypes at my company. We actually built things similar to this for our server HSMs, but they're too expensive for home nodes. Like if you're trying to fit all of the requirements that you want, including like RAID 1 mirrored disks, and to have enough speed and features, it costs way too much to make a custom solution. But I designed this with a European board designer. They normally make boards for factory controllers. You know, in a dirty, dusty environment, their controllers need to not fail in 10 years. That is a very different a level of quality than a Raspberry Pi. But luckily, there are other choices. Okay, Raspberry Pis are dangerous. And Lightning is a 24/7 online server. And Lightning, you need real-time backups of your state database. The static channel backups are not a backup. They're lying to you. It is only an emergency recovery procedure where all of your channels close if you ever use it, and there is some risk of losing money. It's better than not trying to recover your funds, but it's like, it should be your last choice. You should have 2 storage medium to save every state update for your Lightning node. Yes.
When you say there's some risk of loss, is that if the counterparty is dishonest?
They may be offline, like you can't do it. Yeah. If they're dishonest, you know, they could lie. but they are at risk of losing everything as well. So, it's complicated. But actually, many of these nodes themselves have lost their database. So both of you will not get your money back. So if you are running a Lightning node, you want 2 disks. They don't need to be on the same computer. I can talk about that later. Yes.
Is there a risk that the static backup will not be up to date?
Yes.
Like,
Yeah.
if there's a crash and
Yeah.
an update isn't fully written to disk or something.
So normal people, if they have automated backups, maybe they'll have the latest static channel backup. They may not have the latest Lightning database state. Okay, so we make Core Lightning one of the Lightning implementations. Our recent release, March of this year, included social backups. And social backups means you and your friend can back up the other node's channel or static channel backups. I think it's encrypted. I've not tried it myself yet, but I hear it's pretty good. This is still better than nothing, but I say do not rely on static channel backups because there is some risk, and all of your channels will close. That can be very expensive, especially recently with the mempool pressure being high. Okay, now other risks. So it's not only Raspberry Pi that's unreliable, lots of other machines. Most of the hobby boards that you buy are not good quality. I would buy pretty much only business class machines. But fortunately, this is now possible to do cheaply. Now, other things to watch out for is you want more than 1 disk. I talk about this more. And do not rely on USB, and especially do not use an external USB disk. There's the risk that someone will touch that cable and then your data could get corrupted or the system will crash. One of the reasons Raspberry Pi is a little less stable is all of its storage is via USB. And the USB bus itself is usually not stable compared to the other ways to plug a disk into a computer. Okay, so I go into examples of basic hardware requirements, but basically any old used PC, Chuko Pasakon, you want to be 64-bit, so maybe 10 years or newer. You want 2 internal drives, no external drives. If you get recent computers that could use SATA or NVMe 2280, these are the lowest cost drives. For Bitcoin recently, if you want a full node, you want, unfortunately, 2 terabytes if you're building a new node now, so that it will last a few years, plus you can run a few other applications on your home server. One way that building your home node now is the lowest cost ever is that SSD prices are at an all-time low now. I don't know what it costs in Japan, but in America, here are drives that I recommend, and these prices are maybe 50% of a year ago. So, and I recommend particular types of drives, like TLC is a higher quality of flash than QLC, and you want DRAM cache, not HBM. HBM means the cache is in the computer's RAM. That's not a good idea. for safety. Now, there are other even cheaper SSDs with SLC cache. I don't know if that's safe. I think we can share these slides later so people can review this. Okay. Now, when I say choosing the used PC is very, the choice is very important because there are other drive types that are a lot more expensive. And I have some examples of that. So to make it easy, here are models that are the best used PCs right now for building your home Lightning node. And it's particularly these models I recommend because they are very plentiful. They are a business economy model, so high quality, but they're very heavy, so people don't like them. So the companies are selling them now. These are 2018 and 2019 models. Now, models newer than this are actually worse, and I have an example later. So there are other brands. I don't know other brands. Maybe you could make a guide for other brands of PC makers if it has a similar requirement or if it meets a similar requirement. So, for example, Teruko, Neriki-san, recently bought this machine used in Japan, a ThinkPad E490. And I recommended this machine because it has a NVMe 2280 drive and a SATA drive. And that makes it, you have two internal drives, and these are very common, so it's a lowest cost. So on the left is before, when she received it, and on the right is after, when we upgraded both drives. And we also added another memory stick. You can buy these used, and they're almost always perfect. Now, there's a cheaper way to do this because you don't actually need two 2 terabyte drives anymore. So if you buy the used PC, it probably comes with a small drive. In this case, it came with a 256 gigabyte NVMe drive. So we could have added a 2 terabyte SATA drive and use it in a big plus little configuration. Because on your Lightning node, only the database is important. You don't need to keep 2 copies of the blockchain, for example. But this is more of an expert level, a more expert level setup because if this drive fails, you can recover from this drive, but you have to know what you're doing. If you have 2 identical drives, then it's easier to recover because you remove the dead drive, you add a replacement drive, and then you copy everything over. It's a lot easier if you have 2 identical drives in size. Okay, so here's another example of it works, but it's complicated. So on the left is a older ThinkPad A485. This is actually similar to most laptops. So in this case, it has an NVMe 2280 bay and a WWAN, normally used for like an LTE modem or 5G modem. And many laptop models, you can actually plug in a SSD into the WWAN port, but there's many compatibility problems, and it works in only certain models. It's kind of a big mess. So here is, this is actually a very recent model. So I recommended the E490, that's a 2019 model. This is the 2021 model of the same thing. It's pretty nice. Like it has the 2280 drive slot, but the second drive is a 2242 drive slot, and these are rare and expensive. You can buy this in 2 terabytes, but it might cost a lot more and it might be less reliable because it's only sold by Chinese brands. So for this reason, I recommend particularly those 2018, 2019 models, and they don't make good machines anymore. Maybe the other brands do, I don't know. I'll skip that, it's complicated. Okay, so if you do add a SSD to your WWAN slot, there is a modification that I discovered to make it more reliable, where you block off it looks like wireless disable and full card power off. Those sound bad. So I blocked that off with tape, and it made it work in some laptops. But this is still a risk. Like, don't buy a machine of this type, but you might be able to take an existing machine of this type and add a small SSD this way, and this might even work for other brands. I don't know. So online, you can search about this. There's a long list of models that support a WWAN port SSD, and it's like yes, no, yes, no. So you can find many of these machines in the used PC shops. Like here in Tokyo, I bought one last year. Now, there is a risk when you buy used, and the shops don't let you properly test it, so do not ask permission. When they're looking away, insert a Linux Live USB and then reboot into it to test that it runs Linux properly. Like, the people working there have no idea what you're doing. Like, just don't ask permission. Okay. In Linux, you're better able to look at things like, is the disk going to fail? Like, do all the devices work? Like Windows that it has as a demo, it's not easy to test these things. With a used PC, like especially ThinkPads, it has a self-test in the BIOS menu, but you have to know how to shut it down properly because Windows lies to you. Shutdown is not shutdown. It's actually suspend to RAM. So you have to hold down Shift and then shut down, and then you can use the BIOS options to test the memory, test the system. There is a quick self-test that's like 5 minutes, and that's short enough that you can do it in a store before you buy it. Yeah, don't ask permission. Okay, so my examples are only ThinkPads. You probably know other brands. I don't have time to research them, so you could make a guide. So on a ThinkPad, if you hit F12, you get the boot menu on the left, and then you tab over to the app menu. Setup is the BIOS options. The splash screen will tell you what machine it is, the CPU, the RAM, and the disks. And the diagnostic tools is a self-tester. So you're able to test a lot even before you buy it. When you set these up as a home server or a Lightning node, I recommend these options. Power on, AC attach means the machine will come back after a power outage and the battery had died. For a server, that's good. Some models don't have this option. And you also want to turn off network boot, also known as PXE, or UEFI network boot. It's a security hazard. Other options, so these are extremely common in the US. In the US, there are sellers of this with hundreds and thousands of these from like 2017 through 2020 models. I bought this for $40. And they have laptop CPUs. Their power usage is very low. Like the amount of RAM can be very large, but the most important thing is they have 2 low-cost drive bays, NVMe plus SATA. So any of these you buy cheap enough will be good for this purpose. I don't know if these are in Japan, but these are really cheap in America. Okay, so there is a different way to have real-time Lightning database safety. If your machine has a single disk, do not add an external disk for a backup. You can instead have a remote file system, and the Lightning node software can be told right in these 2 locations. One is local, one is remote. And that is pretty good safety. And this will work with any hardware. Okay, so now we do a live install demonstration. Okay. Okay, so this is a ThinkPad E490 that Nariki-san bought recently. And currently it's installed with Linux. We're going to reinstall it from this USB stick. Okay, so it's rebooting and it's not going to show. It went into the BIOS menu and I'm selecting USB HDD to boot from the USB stick. Okay, so this is Fedora 38 Live Workstation. It's simply the fastest to install from a USB. It's not the best choice for a server install. Okay, I've not done this in Japanese before, so let's try this. Okay. I think it's saying this is a pre-release. Okay. This one? Yeah. This?
No.
This? Okay. Okay, keyboard's Japanese. The time zone doesn't matter. Let's set up the disks. Okay, so we're... In this case, it has 2 2-terabyte disks. So we're going to select both of them. And then go to custom drive something, you know. And then done. Okay, so it currently has something installed. We're going to erase everything first. Okay, delete that. Okay. So we have 2 disks, and we want both disks to be identical. There are some hazards with the way I'm installing this, and I'll explain this afterward. So I'm choosing software RAID, and then on both disks, and then RAID 1 makes it a mirror, so it's identical on both disks. And in this case, we want it to be the EFI system partition. It needs a small partition to boot the system. And we're choosing this to be 128 megabytes. What's this? Label. Wait. Okay. I think the name. Okay. The software RAID array. It's optional. Think that'll work. And then I don't have time to explain why. This is just the minimum requirement that it needs to install and boot. Okay, so it needs a EFI partition to boot from, and that is a RAID across both disks. Now I'm creating a boot partition, also software RAID, type ext4. I'll just give that a name of bootfs and md1 and mount point and size. It needs to be over 500 megabytes. So I'll just call this 600. Oh, okay, I did that wrong. Okay, need 2 drives and RAID 1. Okay. $600 megabytes. How's your time?
Okay.
I don't know when we started. Okay. Okay, so for most of the drive, we're using BTR. Oh, wait, no, this is the wrong choice. We want BTRFS. Okay. Okay, so we're not using software RAID. We're using BTRFS. If you're familiar with Unix, it has similar features to ZFS. It's good enough for a 2-disk home server. So in this case, the file system is what manages the mirror across both drives. And we're giving it all of the remaining storage. And we'll give this a name of root and mount point of / okay. And hopefully this works. Here?
That would reset it.
No, here? What?
P, right.
This? Yeah. Okay. Oh, okay. Here. Okay, so it tells you everything that it will do. So it's deleting the old arrays and the old partitions, then it's recreating them. And this is accept?
Yeah.
Okay.
And start installing.
Yeah. So a normal Linux install can be very, very slow, but if you install from a live USB, it's actually pretty fast because it's copying the file system directly from the live USB. So this will have things like Office applications and a web browser installed that you don't actually want on a server. Okay, while that's going, I'll explain something.
I have a question.
Yes.
While you're doing that. Well, obviously, this is one way to implement what you're installing.
Yes.
It's different ways. In my opinion, what I did, I do have mini PC with two SSDs.
Yes.
The two SSDs are configured as RAID 1, but it's CFS call it a little bit different, but it's similar to BTRFS.
Yeah.
CFS,
Yes. Yeah. Okay. There are many different Linux. There are many different ways of installing RAID 1. I'm demonstrating one way. Now, I recommend BTRFS because it has been the default in SUSE Linux for I think 8 years, and Fedora for a few years now. But it's particularly good for the big plus little configuration, where you have, for example, a 2 terabyte drive and a small drive. In that case, you would install it in a similar way to this, only on the 2 terabyte drive, while the small drive is blank. And then later, you can add the small drive as RAID 1 only for the Lightning data directory. So BTRFS is very flexible in letting you add RAID 1 only for particular data, and you can do it later. Now, other file systems like ZFS, I think you can also do that. Yeah. Installing and configuring it with ZFS or a different Linux will look completely different from this.
What I was going to is, so you will install the operating system, and then once it's installed, you will install which implementation of Lightning? For Lightning or?
It doesn't matter. You can choose whatever you want.
Yes.
Right now, I'm only demonstrating the base system with the operating system with 2 disks. Yeah.
So, how is the RAID handled differently in the different partitions that you set up?
Okay, so let's see if we can see this. Okay, so in this case, we created. Oh yeah. We created 2 Linux software RAID arrays for boot EFI and boot, but we are not using Linux MD-RAID for the main root FS because BTRFS is better at managing its own mirror. And the problem with RAID 1 or the old style of RAID 1 mirrors is that it's mirrored at the block level and it's not able to detect corruption. So silent corruption can happen, and if you're using a file system like ext4 that doesn't know, then your data can be corrupted and you have no idea. BTRFS is a check-summing file system where it's able to detect corruption, sometimes even correct it. And if it manages the underlying block devices directly for RAID 1, it can be more intelligent about trying to recover from silent corruption much better than an old style RAID array. But the reason that I use the old style block RAID 1 for boot is that the other boot tools don't understand the like BTRFS. Yeah. Okay, so that's actually done. So we can reboot into this.
Also, what do you think about using hardware RAID for these things?
Hardware RAID might seem easy, but it has the same problem of not being able to detect silent corruption. And Linux may not know how to ask the RAID controller about the drive health because it's giving it like an abstracted storage device instead. Like the performance and the self-reporting of Linux software RAID actually has been quite good compared to hardware RAID for many years now. Okay. Okay, so this is the Fedora operating system now installed on 2 disks. We can see there are 2 drives of identical size and this file system is across both. Now, what do you do with this? So things like Umbrel, they distribute in Docker containers. Who has tried Umbrel? Okay. So I think they only explain how to do it on a Raspberry Pi easily. They also support ordinary PC Linux in Docker containers. I have no idea how to install that. You have to find their instructions. That might be one easy way of doing it. You could also manually install like Bitcoin Core, Core Lightning, LND, RTL, mempool, BTC Pay server. You have a Linux server here. You could follow all of the ordinary Linux installation instructions for that. So today's demonstration was only to get reliable hardware on two redundant disks. I don't know. Do you have any questions? Okay.
So if one of the disks were to die, then is that alerted? Is it through the GUI or like how would you?
Okay, that's complicated. So unfortunately, this type of install with 2 disks puts you into low-level sysadmin skills. Like you need to learn how to look at the health of your disks. I know how to do it at the command line. I'm not so sure if there is like a GUI option. Let me see here.
I mean, even if it's, I was just wondering, is it? Do you have to go and look for that, like regularly check the health of your disk, or is it going to tell you? Is it going to show up in the logs or?
There are things you can install that. So, for example, where's the plus key on this keyboard? Oh, okay. Okay. Your password is owner.
Okay.
Smart. Okay, so there is a tool in Linux called smartctl, and that is everything you need to test and report the health of your drives. I think this is the package name. This will take a little while. So if you read the instructions for SmartMon tools, I think it has a way to enable a service that can email you if it detects new problems. I've not actually used it.
So how do you do it personally? Are you actually proactively monitoring that, or?
I like every time I log into my server, I run where's plus again? Okay. I run dmessage and I just look at this, and if there are any disk errors here, then like I look at this maybe every week. If you have two identical disks, you don't need to check it very often. Now these errors are I don't know what this is. Okay.
You.
Okay.
You one.
Okay, but it's not a disk error, so you're okay.
Just to add, you can use Prometheus in Grafana, and you can have a GUI that will tell you if the disk failed. I mean, like Warren said, you install tools like Prometheus, Grafana, and you have a nice GUI that you don't have to look at the scope.
Okay, so he said that there are tools like Prometheus and Grafana. There are many different monitoring tools for Linux servers. So I'm just demonstrating the basic use of SmartCTL after this installs. SmartCTL is available on any Linux. So -A will give you information. Let's do -X, which is the way too much information. And 1, that's the first NVMe drive. Let's pipe that to less so we can scroll through it. Okay, so this is a Samsung SSD 970 Evo Plus 2 terabyte. Gives information. How much power it uses. Wow, this one uses a lot of power. The current temperature, and the important things are down here, like errors. I thought it gives more information than this. Maybe it's in -A. Huh. Let me try the other drive. Okay, so here's the second drive. This is the SATA 2 terabyte drive. In this case, it's reporting the raw data, power on hours, erase fail count, program fail count, write error rate. So, like these errors and fails should be 0. Like the moment they begin to have even a small number, that's a good sign that you should copy your data off of it.
Maybe you didn't get this information on the other drive because SmartCTL probably is not supported on the other drive. Sometimes.
Yeah. Yeah, there is a different tool for querying NVMe drives. Where's small tick? It's a Japanese keyboard. A single quote.
So
There, okay. Oh, no. Star. Okay. Yeah, so the NVMe tool is a different package. Yeah. Okay. Questions? Okay. I actually have one more of this with me, if someone's interested. But you should be able to buy these in Japan as well. Okay.
yeah, it costed me around 3万円.
I have one more question.
Yeah.
That's it. So You mentioned earlier on that there was they don't make good computers anymore.
Yes.
I found that in my own experience as well. Do you have any thoughts on why that is? Is it something like fiat related? It looks like a kind of shrinkflation, or is it just because like the manufacturer's resources are all focused on mobile devices now?
Well, in the case of this model, like this is like a transitional model where it has both the old and the new drive type. But they're moving away from SATA. You know, it's less materials to make NVMe, but it's actually higher cost motherboards to support it. So it's a balancing act. So the newer models of this support only NVMe, but they don't give you two full-size 2280 slots, which makes it more expensive to have two drives of the same size. Please follow me on Twitter. I also have there is a Twitter community. Where do I have that? If you follow me on Twitter, you'll see that I have a Twitter community where people post advice on used PCs for Lightning nodes, because there's many different choices to buy. Where is it? Yeah. Okay.
I can post that.
Yeah. Okay. So the slides and the community will be available from Diamond Hands. Thank you.
Thank you.